Section 26 is entitled Adding and Subtracting Mixed Numbers. Remember that a mixed number has a whole number and a fractional part. That's a mixed number. And we can convert this number to a fraction and improper fraction. So those are just words, just a fraction. 7 times 5 is 35, plus 4 is 39 over 5. You don't have to think, oh, it's improper. Doesn't matter. Okay. So suppose you wanted to add 2 3/4 plus 4 2/4. Now, if what you can do here is add the quarters. You will have 5/4 and you would have 6. 2 plus 4 is 6. Now, I want to make this clear. This means 6 plus 5/4. 6 and 5/4. If you have $2.50, well, you have $2 plus a $0.50. Some students think that 2.5 means 2 times the half, which is 1. No. That is not true. 2 times a half is 1. But you need to put the times symbol. There's no symbol in between those two numbers. That means to add. Well, unless you have 78, that doesn't mean to add 7 and 8. But if you have a whole number and a fractional part next to it, and no sign in between, in this case, this means 78 plus a third. Plus. So let's go back to our little problem. 5/4 is improper. It's 1 1/4. 4 goes into 5 one time with 1 left over. Now you can add these two numbers with no additional steps, fine. But 6 is 6, and 1 in the plus is plus. 1 1/4 means 1 plus a quarter. So now we're almost done. 6 plus 1 is 7, plus a quarter. Why, that's 7 1/4. The answer is 7 1/4. You can do it with less steps, good for you. But I showed every step that can be written. And 2 over 11. You want to add 8 3/4. First, we should get, for the fractions, a common denominator. You have 2 over 11, and you have 3 over 4. The first common multiple will be 44. So I want to multiply top and bottom by 4. That is, I'm multiplying by 4 over 4. That is, I'm multiplying by 4 over 4, and I'm going to get 8 over 44. And in the bottom, I'm going to multiply the top and bottom by 11, because 4 times 11 also gives me 44. And 3 times 11 happens to be 33. So what I'm really adding is 7 and 8 over 44 and 8, and 33 over 44. The fraction parts, the denominators are the same. Add the numerators. 8 plus 33 happens to be 41. And 7 plus 8 is 15. And this number is proper. That fraction is proper. The answer is 15 and 41/44. And you should ask yourself, can you reduce this? The only numbers that go into 44 are 11, 4, and 2. None of those numbers go into 41. So that's your final answer. Get the denominators to be the same. If you have 8 and 5/7, and you want to add 9 and 4/7. I think it's obvious you don't have to get the denominators to be the same for one simple reason. They are the same. They're both 7. So, 7. Add 5 plus 4 is 9, and 8 plus 9 is 17. Thing is, the fractional part is improper. I mean, this is correct. We didn't do anything wrong. 17 and 9/7. The thing is that we're not done yet. For example, somebody says, what 8 plus 2 plus 4 plus 5? You can say, well, 8 plus 2 is 10 plus 4 plus 5. And I would put a big check mark there saying you are right. But you're not done because you didn't finish adding the numbers. 10 plus 4 is 14 plus 5. Yep, that equal sign is correct. When I grade exams, all I do is look at equal signs. Are they right or not? That's correct. Will you get full credit? No, because you're not finished. 14 plus 15 is 19. Okay, we just are not done yet. This means 17 plus 9/7. But 9/7, well, 7 goes into 9 one time with 2 left over. Now, if you like, you can just line this up and add them. You get 18 and 2/7, and that's your answer. Or you can say this is 17 plus 1 and 2/7 means 1 plus 2/7. That's 18 plus 2/7. 18 and 2/7. However you get it, get 18. However you do it, get 18 and 2/7. And 2/13. You want to add 48 and 7/13. The denominators are the same. Keep it as the numerator. 7 plus 2 is 9. 22 plus 48, add them, you'll get 70. Since this fraction is proper, that is your answer. 70 and 9/13. 70 and 9/13 is your answer. If you wanted to do 8 and 3/4 plus 12 and 1/5. First, you have to write these with common denominators. 3/4, 1/5. The first common multiple is 20. 4, 8, 12, 16, 20. Remember, anything that ends in a 5 or a 0 is on the 5 table, and nothing else. Only numbers that end in 5 and 0 are on the 5 table. 4, 8, 12, 16. I'm waiting to get a number that ends in a 5 or a 0. There it is, 20. I multiply by 1, top and bottom by 5. I get 15/20. Multiply by 4/4. I get 4/20. 1/5 is 4/20. 3/4 is 15/20. 3/4 is the same as 15/20, and 1/5 is the same as 4/20. Anywhere, it's 20 and 19/20. There's the answer. Problem If the denominators are the same, just add. And then if the fraction part is improper, finish off. If it can be reduced, reduce it. If the denominators are different, then get them to be the same. Now, we need to talk about how you borrow. Suppose you have 7 3/5, and you need to borrow. Because maybe you want to take away 2 4/5. You can't take 4/5 from 3/5. You have to borrow. Now, 7 3/5. If you borrow here, if you borrow from there, some students may say, well, you make that 13/5. Well, if you borrow 1 from here, you can only add 1 there. If you have 3/5 and you add something, and I'll give you a hint, let it be over 5. And now you have 13/5. Well, in addition, if the denominators are the same, keep it, add the numerators. 3 plus 10 is 13. The problem is you didn't add 1. You didn't add 1. If you have 8 4/7 and you want to borrow, and you say, well, I make this 7 and I put that little 1 next to the 4. Hey, is this correct? You have 4/7. What are you adding to it to get 14/7? And the answer is you're adding 10/7. The problem is that's not 1. You borrowed 1 from the 8. You borrowed 1 from the 1's place, but then you didn't add back 1. You didn't add back 1. You have to be a bit more careful. You just can't blindly say, oh, I know how to do this. I borrow, I make this 1 less, and I put a little 1 there. That's not true. It's not true in this case. And why is it true in other cases? If you have 834, I'm borrowing, these are the tens position. I borrowed 110. Well, 110 happens to be 10 ones. 110 is 10 ones. And when you add 10 to that number, just put a 1 in front. If you have 3 and you add 10, you get 13. That is, you get this number, 3, with a 1 in front. And if it were 8, you get 8 with a 1 in front. 7 plus 10, you get 7 with a 1 in front. This is true in base 10, but we're not in base 10 if the denominator is 11 or 4. So let's see what we do. If you have 7 5/11, if you borrow from here, well then you have to add 1 over there. Well, 5/11 plus 1. Well, that's 5/11 plus 11/11. That's 1. Denominators are the same now. And you get 5 plus 11 or 16. If you have 7/15 and you want to add 1 to that fraction, because you borrow it from the 1's place. Well, think of the 1 that you're adding as 15/15. In addition, the denominators are both the same. Keep it, add the numerators. If you have 8/11, and let's make it 14. Make it 81/14. And you want to add 1. Well, think of the 1 as 14/14. So then the denominator is 14, and you assured way of figuring out what this is. How do we go from there right to here? And the answer is, to the numerator, we added 11. Oh, 11 was right in the bottom. 7 over 15, we want to add 1. So to the numerator, we added 15. And we added the bottom to the top. You want to add 1 here? Well, we took the numerator and we added 14 to it. Oh, we added the denominator. If you have 7 over 12 and you want to add 1, well, where am I getting 12 over 12? Why not 11 over 11? Why not 14 over 14? Because I want this to be right there, because they have the same denominator. That is, just add the 12 to the top. So if you have 3 over 4 and you want to add 1, 3 plus 4 is 7 over 4. If you have 2/3 and you want to add 1, 3 plus 2 is 5 over 3. Add the denominator to the numerator. So if you have 7 and 5 over 11, and you want to borrow here, make that a 6. So now I want to add 1 to the 11 over 5. Add 11 to the top. Add 11 to the top. Because you're really adding 11 over 11. Okay, having said all that, let's try to do this. Hopefully now, it wouldn't just be in your mind, oh, you just do this because my teacher said so. Hopefully you'll see it because I showed the why. You're adding 1. So, if you had, say, 34 and 7/15, and you would love to take away 10 and 11/15. Well, I'm not sure what just happened, but go to another page. 34 and 7/15. You want to take away 10 and 11/15. Well, the denominators are the same, which is good. Now you attempt to do 7 minus 11, and you say, oops, I can't. You have to borrow from the ones place. Make that a 3. But don't just put a 1 in front of the 17. Why? Again, if you have 7 over 17, and you add something, and now you have 17, I meant to say 7 over 15, and now you have 17 over 15, you added 10 over 15. In addition, if the bottoms are the same, and they are, keep it, add the top. 7 plus 10 is 17. The problem is that you didn't add 1. 15 over 15 is 1. 10 over 15 is not 1. Again, what you do is you just add the numerator. You just add the denominator to the numerator. You add 15. So it's now 22. 22 minus 11 is 11. 33 minus 10 is 23. The problem is done. You have 88 and 4/5. And you want to take away 12 and 10 or 9/10. 12 and 9/10. Well, first you have to get the denominators to be the same. The first common multiple will be 10. If you just double the top and the bottom, you'll have 88 and 8/10. And you are going to be taking away 12 and 9/10. Well, the denominators are the same, which is good. 8 take away 9 you can't do. You make this a 7. And then you add this number, the number in the bottom, you add to the top. Since 10 is 10, it's in base 10. 10, 100,000. You can just, so you add 10 to the top, which means you just put a 1 in front. 8 plus 10 is 1/8, 18. 18 minus 9 is 9, and 87 minus 12 is 75. And there is an answer. 75 and 9/10. If you are asked to do 87 and 3/7 minus 16 and 5/7, well, the fraction part, they both have the same denominator. Subtract the numerators. Why subtract? Because it says to subtract. But you can't do 3 minus 7. I meant to say 3 minus 5. You can't do that number minus that number. So you borrow. And you add this number to the top. 3 plus 7 is 10. Okay, now we subtract the numerators. 10 minus 5 is 5. And 77 minus 16 is 61. And there is the answer. 61 and 5/7. You have 98 and a half. You want to take away 16 and 7/8. Well, between 2 and 8, the first common multiple is 8. That is, you multiply top and bottom by 4 just on the first fraction, and you'll have 8 on the bottom. So you'll have 4 over 8. And you want to take away 16 and 7/8. Since the denominators are the same, that's good. The answer will have the common denominator. Unless in the end you can reduce it. You can't do 4 minus 7. You don't have enough 8 to take away 7/8. You only have 4 of them. Okay. So you borrow from here. And then you add 8 to the numerator. You have 12 over 7, 12 over 8, minus 7 over 8. 12 minus 7 is 5. And 97 minus 16 is 81. Now, you can think of it like this way. You own a pizzeria, and for some reason, you have a lot of pies on hand. You have 98 pies, and you have one more pie cut into 8 pieces, but you only have 4 of them. You have 98 pies, and 4 out of 8 slices in the 99th pie. And somebody comes in and they say, I want 16 pies and 7/8 of another pie. That is 7 slices out of 8 on another pie. Well, in terms of the 7, so you want to give them 7 slices out of the 8. So you have a pie, you cut it up in 8 pieces. But you only have 4 pieces, they want 7. So what you do is you take a whole pie and you cut it into 8 pieces. So now you have 12 pieces. 12 minus 7 pieces is 5 pieces. So you'll have 5 pieces left over. And you will have 81 full pies left over. You started off with 98 whole pies and 4 slices out of 8 slices. 4 slices out of a whole pie. And somebody comes in and says, you know what, I would like 16 whole pies and 7 slices. What will you have left? You will have 81 whole pies and 5 slices left over. So if you think of it that way, it's kind of obvious or more clear how that you add to the 4 slices, you add 8. So how about this one? A little bit harder, but not much. You have 405/7, and you want to take away 16 and 6/7. So you need to borrow, you can't do 5/7 minus 6/7. The denominators are the same, which is good, but you can't do 5 minus 6. So you have to borrow 1. Well, if you borrow 1 from 400, you now have 399, and you add 7 to the top. That is, it's 12 over 7. Minus 6 over 7 is 6 over 7. And 399 minus 16 is our 383, I guess. And there is an answer. Let's try one more. Suppose it's now 7, so this is a different problem. It's 7 o'clock and 25 minutes. It's 7:25. And you want to know for one reason or another what time it was 2 hours and 44 minutes ago. It is now, you look at the clock, it says 7 hours and 25 minutes. And you want to know what time was it 2 hours and 44 minutes ago. Well, you can do 7 minus 4, which is 1. But you can't do 7. You can't do 2 minus 4. So you borrow from the hours. Now remember, this position is the 10 minutes. How many 10 minutes are in an hour? 6. You add 6. So that is, what you're really doing is adding 60. You're adding 60. If you rather do that from the get-go, fine. You add 60. You take the 1 hour, and you convert it to 60 minutes. And now it's 85 minutes. And I'm not disagreeing with that. 2 plus 6 is 8. And maybe now we'll do the subtraction. You add 60. You add 60, and you get 85. From the 25, you add 60. Okay, so now the problem is, it's like 6 o'clock and 85 minutes, which is 7:25. You want to take away 244. 5 minus 4, 8 minus 4, 6 minus 2. Okay, it was 4 o'clock, it was 4:41. It was 4 o'clock and 41 minutes. 2 hours and 44 minutes ago, if it is now 7:25, 2 hours and 44 minutes, it was 4:41. Let's try one more problem like that. Suppose it is now 9:18. And I want to know, for one reason or another, what time it was 4 hours and 59 minutes ago. Well, you have 18 minutes. You can't take away 59 minutes. So you borrow an hour. But an hour is 60 minutes. That is, you borrow 1 hour, so you have to add an hour here. But that means you add 60 minutes, because these are the minutes. And now you have 78 minutes. That is, to make it more neat, you want to do this subtraction. Now, you need to be careful. You can't do 8 minus 9. But you need to be careful. You need to realize that you're borrowing from the 10 minutes, so you can add 10 minutes to it. You're borrowing 1 10-minute, and you're adding 10 minutes to the minutes, which is allowed. 6 minus 5 is 1, and 8 minus 4 is 4. If it is now 9:18, that was the first number, and I want to know what time it was 4 hours and 59 minutes ago, the answer is it was 4:19. Let's try one more painful. We're going to have to borrow even more. Suppose 1 day, 22 hours, 48 minutes. Too many hours. Let's make it 20 hours. Make it 20 hours. And you want to take away 22 hours and 59 minutes. So you have 48 minutes and you want to take away more. You can't do that. So you borrow from the hours. You now have 19 hours. And you add 60 to this number. Because 1 hour is 60 minutes. 108 minutes. 108 minus 59, if I'm not mistaken, is 49. Now, okay, that's done. The minutes are done. Now we go to hours. You have 19 hours, you want to take away 22 hours. Don't have enough. So you borrow from the days. Now you have 0 days. What do you add? You just don't put a 1 in front. You add 24. You add 24 hours. Because 1 day is 24 hours. And 19 plus 24 is 43. You have 43 hours and you want to take away 22 hours. So you get 21 hours remaining. 21 hours and 49 minutes. If at some time you run a clock and the length of time that has elapsed is 1 day, 20 hours, and 48 minutes ago, and somebody asks you 22 hours and 59 minutes ago, how much time had elapsed back then? If you go back, if you take away 22 hours and 59 minutes, how much time has elapsed from that point? The answer is 21 hours and 49 minutes. And a cost to check would be if you add up, I'm saying this whole length of time was this amount. Well, this portion, 2149, plus this portion, 2259 is the whole. In fact, as you always know, 9 minus 4 is 5. If you add the 5 and the 4, you should get 9. If I add this and this, I should get the top. Let us actually try that. Now remember, any minutes over 60, you can convert to hours. 59 and 49 is 108. 108 minutes. And when I add this up, I get 43 hours. Okay. Well, I can carry over. I can take 60 minutes from here, make this, and put the hour there, and then I have 48 minutes left over. I converted 60 of these minutes. 60 plus 48 is 108. I took the 60 minutes and I carried it over. In fact, why don't we do that? Let us keep this as 43, but I carry over a 1. So now I have 44 hours. Okay, the minutes are fine, it's less than 60. But the hours are too much. 44 hours is 24 hours plus 20. And 24 hours is a day. So, and right now I have 0 days. I can take away the 24 hours, so now there's 20 hours left over, and I make the 24 hours a day. And I get 1 day, 20 hours, 48 minutes. Hopefully that's exactly what's on top. Hopefully you understood this. This is a hard one, because sometimes you carry over 24, because 24 hours are in a day. Sometimes you carry over 60, because there's 60 minutes in an hour. You have to be careful. You have to understand what's going on and not do it blindly. If you do it blindly, well, you're not going to do well. Okay, good luck with this.